And the derivative of log of x with respect to x equals 1 over x. Yeah, so this becomes the derivative of log and then the sum over wj of e to the vwj transpose vc. Yeah. Times the derivative with respect to vw of this one. Yeah, the sum over wj e to the vwj transpose vc. Yeah, dot product here. Alright, and this, because of this rule, this is 1 divided by the sum over all words. The sum over all words. Yeah, E VWJ transpose VC. Yeah, this is this term. And here again we have an F and we have a G. So here again the change rule, the chain rule, sorry. So let's call this number 3. So number 3 in this case is the derivative of E remains E. Yeah. So in this case, number 3. So the derivative of e to the power of x equals e to the power of x. Yeah. So here you see that this sum will disappear because you take the sum of the derivative with respect to VW. So all the other derivatives will be 0 because there will be no VW in there. Yeah? So basically, if we change VWJ to VW, we can basically eliminate that sum, right? So we're gonna eliminate that sum, and we're gonna have that this is E to the power of VW transpose VC. Yeah, this is gonna be that one. Alright, so this is gonna be E to the power of VW transpose VC. Yeah. And this one I'm gonna take away for the time being. Alright? So, where are we? Well, we're still here. So the derivative of the log likelihood with respect to VW equals, well, we have this one here. Yeah, that is V. Now if we take the derivative of this one, then only thing left is VC. Okay? So the derivative with respect to VW of this one is VC. Yeah? And then we have minus from this minus. And then we have 1 divided by the sum over all words, e to the power of VWJ transpose VC times, then we have this one, e to the power of VW transpose VC. Yeah. And then we still have here, I forgot about that, we still have the derivative of this one, right? Because of the chain rule. And the derivative of VWJ transpose times VC with respect to dVW. Yeah, this also gonna be VC, yeah? Right? So this is gonna be also VC. So we have times VC. All right. Now this here is that one, right? So this is the probability of a center word given the context and given the parameters theta. So that means that the likelihood, the log likelihood with respect to VW, we have VC times and then 1 minus PWC theta, yeah, right? And remember, I left this one out, yeah? We need to do this over all words. Yeah, so basically what we're gonna do is we're gonna do that over all words WJ. Yeah. Okay, these are all words in the vocabulary. So J will go from 1 to vocabulary. All right. So if we want to do gradient descent now, because now we have our objective function, the next step is gradient descent. Gradient descent. Yeah, and basically VW new is going to be VW old minus the learning rate. And then this one here, VC times 1 minus PWC theta. Yeah, so here again, I leave the sum out. We know that we're gonna have to do this sliding the window here. Yeah, so this is gradient descent. And what we see here is basically, it shows that it's not very practical, because what we have here is, we have here our softmax. So this is very expensive, because basically you sum over all words here, and you've got to calculate this term for every iteration you do in gradient descent. So it's massive. Yeah? Keep in mind that the vocabulary can be millions of pages on the internet. So it's not very practical to do this. All right? So we need a few tricks.